Hi, and welcome to this 7th video on this series on intermediate Python. So in this video I want to talk about inspection. So in Python one can take any object and basically inspect that object at runtime. And this is a pretty straightforward thing that people have seen in some simple examples, like using the dir function or the div function or id function in Python. This is quite usual and quite common. There are many things you can do with inspection. So in this video I want to delve slightly deeper than what you might have seen previously about inspection of objects and see how this works in Python. Here we are as usual in a Jupyter notebook. I've written some of the code from before, as you can see here when I scroll down, but some of the code we'll also write together. So first of all, the basic idea of inspection is that we can check properties of an object at runtime. So to see why this is useful, here I've written a simple example. So here we have a function that's called insert key value pair. So you take a dictionary, you take a key, and you take a value, and you essentially insert the key value pair. It simply checks that the key is not already present, then it inserts the key with the corresponding value and returns the dictionary. So it's a pretty straightforward function. And here we have some people that we want to try this on. So it's Eirik 28, Stine 28, and Bob 35. And just to make sure that we understand the function, so when I do insert key value pair of people with the data, say Jane, and let's say that the number is 37. Here you can see the outprinted version and it simply adds Jane with a value of 37. So exactly as one should expect. However, since we're not really checking the structure of anything at runtime, things can go wrong. So what you can do is, for instance, to use insert key value pair again on people, but this time, instead of simply using John and let's say a number 26, say this came from a database call and this was returned as a tuple with a single element. So this will look like this. Then when you do this, you see here that everything kind of works, but not in a good way. So it works in that nothing breaks, and this is really inserted as a key and a value. So now the key is John in a tuple with a single element. And the reason, of course, this is not so good is for many reasons. If you try to now extract John, because you think everything went fine, you'll simply get here a key arrow saying I have no idea what John is, because the key is the tuple with a single element of John, right? Let me just return the way we had it. Some other programming languages are statically typed. In that case, you have more control over what's passed into functions, but here in Python, you can strictly speaking pass in a tuple here instead of what we might expect, which is a string, and nothing is really stopping it so far. So what you can do in Python is to inspect the object at the runtime. So let's just go down here to where the action is happening. So say now that I only want to insert the key if the key is actually a string. So one way to do this is to say that if, and then I can use the function isInstance, and then I take the key and ask that this is a string. Maybe I also want the value to be an integer. I can do both of them like this. Then if this is the case, we do the operation. And if this is not the case, then let's simply print out a nice message. Data types, are wrong. I think that's good. Now when we run this and we try to do this here, we simply get the output the data types are wrong and nothing is inserted into the dictionary. So this isInstance function is a built-in function in Python. It takes a value and checks if it's an instance of this class here. And this is simply one of many ways of inspecting an object at runtime. By that we mean that we take an object, here the key, and inspect it while the program is running to see if it has the desired structure, you could say. So here the question is if key is really an instance of the string class. And for the isInstance method, it's really asking if it's an instance of the class or of any subclass of this. But this here will disallow me from entering, say, a tuple with one element, because tuples are not instances of strings, right? So what I thought we can do in this video is to go through some of the ways you can do inspection at runtime of Python objects. And the isInstance is one of them, and many of the other more interesting ones actually lies in what's called the inspect module. So in Python we have several functions for inspecting objects at runtime, and these are in the inspect module. So they're kind of built in the sense that they're in the standard library, but we still need to import them. So let's just import the inspect module. And here we can try out a few examples. The first one is to get the source code of a function. So then we simply, let's also print it out. Then we go to the inspect and use the get source. And here we pass in a function. So let's do the function we had here. Run this, and here you can see the source code. And notice that this thing here is definitely not that useful since the source code is literally right up here. But when you're importing things, it could be useful to simply get a guess of what actually the source code of something is. And just that we understand what's actually being returned here, if you use the type function, so the type function you probably know, it simply checks what type something is. And this is just a string. So here you get a big string of all the source code of the function. So if you now wanted to get a docstring of a function, since this is just a string, you can actually go into this and maybe search for triple quotes after each other and then pick out the value, but that's kind of cumbersome. And anyway, it could lead you into troubles because one, strictly speaking, can make comments like this further down in a function as well if one wants to, even though you probably shouldn't. So you also have a specific function to get the docstring of a function. It's just to print, inspect, and then it's get doc. And here we again can use a function. And here as a string, we get precisely the docstring. So one way this can be really useful is if you're making a library and want to extract some of the source code and docstrings to a web page for documentation, then manually copying things might get things done initially, but when you change something in your library, you of course want the documentation to be automatically updated, and that works a lot better if you script it like this. If you manually copy things and then paste it into a documentation web page, you of course need to do this every single time something changes in the code, and that's of course simply not feasible. So this is one kind of idea for an application where you could use get source or get doc. So I want to give you one more idea that has a bit more flesh on it for inspection using these kind of functions here. Before we do that, I just want to say that the inspect module has tons of functions where you can get which arguments are passed into the function and lots of information about whether something is a function or a class or a generator or whatever. And I simply suggest that you search for the inspect module and look a bit at the documentation page for this specific module. It's super useful. So rather than going through 100 different functions like this, I just wanted to give you some ideas of what you can do using mostly the functions I've shown you here so far. So here is another idea. So the idea is that you're writing plenty of functions, but you're not always sure that you're remembering to write type hints or write docstrings for your functions. And you can go manually through your whole library or whole ecosystem and do this, but it's a lot easier to simply parse the ecosystem, get all the functions, and simply check whether things are the way it should be. This is not a full-fledged application I'm showing. This is just how to get started writing something like this. So you'll probably need to write something like a few functions that checks if another function that is passed in has a docstring or not. You can just, for instance, use the getDoc function. This is a string, so you can just check if it's really the empty string or not. So this returns false if it's an empty string, meaning it doesn't have a docstring, and it returns true otherwise. Secondly, you can write a different function called check for type hints that checks whether all arguments have type annotations. This is sometimes called type hints. I'll actually cover type hints in the next video, so if you're a bit unsure about this, don't worry too much about it for now. So you can use the function getFullArgSpec to get basically any kind of information you can think about regarding arguments. So in here, you can check how many arguments there are. You can also check how many annotations there are, or type annotations, and then simply return if these values are the same. Because if there are as many annotations as parameters, that means that everything has been annotated. That's great, and this will return a true value. If everything hasn't been annotated, then this is strictly less than this, so this will return false. Here we have two checking functions, checking whether a function behaves in the way we want to. We can collect them in a list called quality checks. And now we kind of have just a master function, or whatever you want to call it, pass quality check. I guess you could call it checks with an S since it's plural. And here it just checks if all the quality checks pass. So it loops through them. If it doesn't check one of them, then you return false, otherwise you return true. So this is slightly suboptimal in the sense that pass quality checks doesn't really tell you which check is failing, simply returns false if one of them is failing, but I'll just leave this for you to work out if you're interested. So now we can try this function here. So let's try it on something that someone else has written. So let's go into, say, pandas and import read CSV maybe. Then we check this, and here we get the value true. That means that the readCSV function both has a docstring and has type annotations for all the parameters. That's great. If we now, instead of using someone else's function, checks our own insert key value pair function, recall that we had this function all the way up here. This has a docstring, so that should kind of pass, but it doesn't really have type annotations or what I call type hints, so this should not pass. And as you can see, if I run this, I get the value false. So alongside with something that parses all your functions from all your files, this here is a nice little application to flag function that needs some work done. And honestly, there are quite a lot of third-party applications that work kind of like this that isn't really that much more complicated than this. The application goes as follows. It goes into your library, it parses the library for all files that have a Py extension, goes into each of the Python files, retrieves all the functions and possibly classes, checks that they're behaving in a good way with some functions like this, prints the output nicely so that you can start working on improving your code. And you can see here that once you start inspecting objects at runtime with the inspect module, such applications doesn't really seem that difficult to make anymore. Don't get me wrong, there are definitely some great applications for doing this, they're super useful, but hopefully by seeing this, it doesn't seem like a Herculean task or something like this to actually create something like this. Some of these applications are actually quite small in terms of how much code they have in them. And this is simply due to how nice it is to inspect objects at runtime in Python. So there you have it. In the next video, I'll talk about type hints. So I'll see you again in the next video.